Right now, there is an intense fixation on picking the smartest AI model, finding the perfect language engine that crushes the latest benchmarks. But all that immense intelligence is ultimately trapped inside a simple chat interface. This creates a severe physical limitation. Your AI can give excellent advice. It can summarize long documents and draft brilliant emails, but it cannot actually execute work. Real business work doesn't happen in a chat window. It happens inside environments like Slack, GitHub, Stripe, and Postgres databases. This diagram illustrates the old way of solving that problem. Connecting an AI to external tools meant building fragile, custom-coded integrations from scratch every single time. And the moment an API updated, those manual connections would shatter. Standardizing the protocols that allow AI systems to interact with the outside world is the technical requirement for making AI autonomous. The architecture that connects the modding to the work, the agent stack, is far more critical than the language model itself. The first layer of that stack is MCP, or the Model Context Protocol. This provides a standardized way for an AI agent to discover and use external software tools without custom glue. But giving an agent standard access to your systems creates a massive, high-stakes security vulnerability. Tool access essentially enables arbitrary code execution across your environment. Look at this schematic of a tool poisoning attack. The seemingly normal tool description passes through the network, but unfolding to infect, it conceals malicious instructions inside its metadata, actively hijacking the agent. Mitigating that threat requires strict security measures. Tool access is not a simple feature toggle. It demands rigorous scope boundaries, mandatory audit trails, and concrete approval flows. Giving an agent the reach to connect to a database via MCP doesn't guarantee the agent should be trusted to execute the work securely. Once an agent starts working, a secondary problem surfaces. No single AI possesses the expertise to complete a complex multi-domain workflow independently. A procurement agent needs a supplier agent. A software agent needs a security reviewer. This requires the A-to-A, or agent-to-agent protocol. It is the mechanism that allows a primary AI to discover, hire, and delegate tasks to specialized secondary agents. This visualization shows the core primitive of that exchange, the agent card. It functions as a literal, standardized operating contract, defining exact skills, reachability, and terms of service that are scanned and accepted across company boundaries. Relying on coordination protocols inherently introduces friction. Adding more agents to a workflow directly increases system latency and injects unpredictability into the final result. When these long-running tasks activate and agents begin hiring each other in the background, human operators lose all visibility. The ability to intervene disappears. The solution is AGUI, or the Agentic Graphical User Interface. This is a human control layer engineered specifically to supervise non-deterministic AI behavior. Traditional web apps are built for simple call-and-response actions. They completely fail to handle the continuous streaming work of an agent, making AGUI necessary to share live states, new information, and wait statuses. This dashboard demonstrates the necessary interventions. When the agent reaches a sensitive step, it is capable of stopping entirely to request an explicit approval, allowing the human to correct course or cancel the action mid-task. Without a functional AGUI layer to enforce those control points, an autonomous workflow degenerates into unmanageable supervision debt, where humans have to constantly double-check opaque machine logic. While MCP, A2A, and AGUI form the established core of the agent stack, the ecosystem is aggressively expanding outward. There are highly contested experimental protocols fighting for dominance right now. A2UI attempts to safely render structured interfaces. AP2 handles commercial purchases through user authorization, and X42 settles programmatic machine-to-machine payments. Because rendering user interfaces and settling financial transactions are so valuable, these protocols represent an unsettled, highly volatile frontier in the new AI economy. Why should business leaders care about a pile of invisible acronyms and back-end engineering? Because technical protocol decisions dictate the customer experience. If a payment protocol uses a short-term token that forces a user to spend their day tapping to reauthorize microtransactions, they will abandon the product. If there is no proper human control interface to explain what the agent is doing, the user's trust in the underlying model evaporates, regardless of how intelligent the AI is supposed to be. Building successful workflows requires mapping specific human behaviors to the right protocols. Mastering this invisible layer of standards is the ultimate deciding factor for commercial success in the agentic economy.